Hello friends, welcome to my YouTube channel. Today's the name of reaction is a Clemson Reduction. What we use, that is Clemson reducing agent. Clemson reducing agent is a zinc amalgam and excess of concentrated HCl. Amalgam means which is an alloy. One of the constituent metal is a mercury that we call as an alloy. In alloys, always the oxidation state of the metal becomes zero. Now, example for the reference is here the C double bond O. Here both the valences are filled by one is R, another is a H that we call aldehyde. Both are substituted by the alkyl group that we call as a ketone. Hence, collectively it is known as a carbonyl compound. Carbonyl compound is nothing but it may be aldehyde or ketone, which on reduction, the square bracket hydrogen representing the reduction phenomena, the reducing agent is a zinc amalgam and excess quantity of the concentrated HCl is taken. What would be the obtained product is a CH2. CH2 stands for what? Alkane. Here the C double bond O group is getting converted to CH2. Some exemption cases, most of the cases that the C double bond is getting converted into CH2. When the acid sensitive groups are present, in such cases only the difference. Here, in order to express how it is getting converted, so many mechanisms were proposed. Out of them, and important justification or justified mechanism is here the C double bond O group is present, carbonyl group. When it is reacted with a highly electropositive metal, that is zinc, what will happen? Zinc donates its 2 electron. Here carbon and oxygen, the oxygen is a more electronegative element. It tends to pull the electrons towards oxygen. It gets negative charge and it gets positive charge. These 2 electrons are making bond with carbon. As a result, what will happen? CO minus, and here is also O minus. Dianion is a formed one. Here the dianion, when it is reacted with 2 HCl, it gets converted to form 2H plus 2 Cl minus. Here is the nucleophile is there, here is also nucleophile, here is the electrophile is there. Then CH, here is the OH. Then when another mole of HCl is taken, which gets converted into H plus Cl minus, here is a more electron density is there. It acts as a nucleophile which attracts the electrophile, that is H plus. As a result of this, CHOH2 and the bond is extended. Here, while forming a bond with the hydrogen, it lost its electron. That's what it gets positive charge. We know well. Oxygen is being second most electronegative element. It never appears as a positively charged one. Adjacent bond pair of electrons are accepted by the oxygen and gets lost as a water molecule. Now, this the carbon is lost its electron, that's what it gets a positive charge. The positively charged one is called as a carbonium ion. Now, another mole of the zinc that is donated 2 electron, being it is a second electropositive element. Now it gets converted into CH minus, that we call as a carbene ion. Now another mole of HCl, H plus and Cl minus, which gets converted, that the C double bond O group is getting converted into CH2. This is the mechanism of Clemson reduction. Now the examples concerned about the Clemenson's reduction. The first one, within fraction of seconds, how we can able to write the answer is the important one. Reduction phenomena is the square bracket hydrogen. Then we know well in the Clemenson, zinc amalgam and concentrated HCl is given. Then CH3, the C double bond O bond become the CH2, again H is there, CH3 ethane. Here what the phenomena will takes place? Here the 2 hydrogens are added to this side and the 2 hydrogen is added to the doubly bonded carbon atom. It gets the 4 hydrogen atom. As a result, here H2O molecule, that is acetaldehyde on reduction to form ethane. Where if the propanone or acetone is given, what the thing is happened, wherever that the C double bond O group is present, we need to convert that as the CH2, loss of water molecule. Here is also the same, 2 hydrogens respectively to the oxygen as well as the carbon atom. Here the C double bond O group is gets converted 1, 2, 3, 4, 5. Here the 2 pentanone become pentane. Here double bond is present as well as the C double bond O group is present. The important characteristic properties of the Clemson reduction is which does not influence on the double bond, which only reduces the C double bond O become CH2 only. Very important one. Here the CH, CH2, CH2 and CH3 by the loss of water molecule. And very important one under the Clemson reduction. One, here is a ketone is present at 1,3 position. When 1,3 diketone is given, which is a reduction in presence of Clemson reducing agent, which undergoes or which forms only monoketone under rearrangement. Here CH3, C double bond O, CH, CH3 and CH3. Here the 1,3 position diketone is present, which is gets converted into monoketone as well as undergoes rearrangement. Example number 6. Here OH group is present as well as the carbonyl group is present. The OH is an acid sensitive group. When the concentrated HCl is added, that the acid sensitive groups are gets converted into alkyl halide. Here the OH gets replaced by the Cl, that the C double bond O become CH2. Where here is a carbonyl group is there, here is also originally carbonyl group is there, but which is protected by the ethylene glycol. If the only 1 mole of zinc amalgam and concentrated HCl is given, what would be the formed product is here the C double bond O gets converted like into CH2. Here this group is protected. For example, if it is letazimacin hydrolysis H plus and OH minus, what is happened again? Here the C double bond O. Again another molecule of the Clemson reducing agent, zinc amalgam and concentrated HCl is given, that the C double bond O become CH2. Here the aldehyde group is there, orthohydroxybenzaldehyde, salicylaldehyde, that the aldehyde group is gets converted into alkane. OH is given, here is the CH3. Now here is a cyclohexanone is given, the cyclohexanone is getting converted into cyclohexane. And here one reagent is given, AlCl3, alkyl halide, intramolecular, that a Friedel-Crafts alkylation reaction, loss of H and Cl will take place. Second step, the Clemson reduction is given, the CH2 become, that the C double bond will become the CH2, hence the formed product is a indane is the formed product. Like this we call as a indane.